Hello, physical science students. This is Mrs. Lewis, and we're currently starting Chapter 10. And this chapter, as you can see, is a little bit larger than what you're used to. We have 4 sections that cover sound. Section 1, the nature of sound. Section 2, properties of sound. Section 3, music. And Section 4, using sound. As always, with this particular slide, the only thing you need to write down is big idea. Sound waves are longitudinal waves produced by vibrations. And if you remember, longitudinal waves is a type of mechanical vibration. So writing down the entire slide, the main idea of this chapter for Section 1, sound waves are longitudinal waves that travel only through matter. Section 2, the loudness of a sound depends on its intensity, and the pitch of a sound depends on its frequency. So in the last chapter, we had the difference between waves and frequency and how those affected each other. And now it's kind of the same words, but just being used in a different way. Section 3, a musical instrument produces combinations of frequencies that determine how the instrument sounds. And last, Section 4, sound waves are used to locate objects, to form images, and to treat medical problems.
I heard you on the wireless back in 52, lying awake and then tuning in on you. If I was young, it did stop you coming through. They took the credit for your second symphony, wheeling my machine on your technology, and now I understand the problems you can see. I said to children, what did you tell them? Video killed radio star. Video killed radio star.
So what produces sound? Every sound is produced by an object that vibrates. For example, your friends' voices are produced by the vibrations of their vocal cords, and music from a carousel and voices from a loudspeaker are produced by vibrating speakers. So you should have written down what produces sound and that every sound is produced by an object that vibrates. Sound waves is the heading. Please write it down, and underneath that you need to write sound waves are longitudinal waves. And you need the bullet point. A longitudinal wave is made up of 2 types of regions called compressions and rarefactions. You'll see that when a radio speaker vibrates outward, the nearby particles of air are pushed together to form compressions, as you can see right here. No need to write this down. As this figure shows, when the speaker moves inward, the nearby particles of air have room to spread out and a rarefaction forms. Here. As long as the speaker continues to vibrate back and forth, compressions and rarefactions form, much like a slinky, if you needed to visualize that. You have a new heading, traveling as a wave, and for this unit, you're going to write down the page number in your textbook for science where this heading can be found, traveling as a wave. So underneath that, write down compressions and rarefactions move away from the speaker as particles of air collide with their neighbors. Bullet point, a series of compressions and rarefactions form that travels from the speaker to your ear. Next bullet point, the sound wave is what you hear. And as you can see, our heading has changed once more. Now it says traveling through materials, and next to that, please write down the corresponding textbook page number. So writing down, most sounds you hear travel through air to reach your ears. And as we know, sound waves can travel through any type of matter or medium, be it solid, liquid, or gas. Writing this down, the matter that a wave travels through is called a medium, and that's a carryover from last section. Sound waves cannot travel through a vacuum. So the speed of sound through different materials. First of all, you do not need to write this down, but you do need to write down the page number right here where this heading and this table can be found. The speed of a sound wave through a medium depends on the substance the medium is made of, its temperature, and whether the medium is solid, liquid, or gas. So last chapter, we just really talked about more about the medium. We touched on temperature just a little bit, but this time we're talking about two different things. We're talking about not only the medium, solid, liquid, or gas, but we're also talking about the temperature. Bullet point. In general, sound travels the slowest through gases, faster through liquids, and even faster through solids. And again, a lot of this is carryover from last chapter, so hopefully you learned that. I need you to put a second bullet point and write C, table 1, page whatever that's on. And do keep in mind that during the grading process, I will be looking for the bullet point for the table, and I will be looking for page numbers. If they're not on there and or not correct, that could affect your grade. Next bullet point under the heading, the speed of sound through different materials. This should be your, second bullet point. Third. Sound travels faster in liquids and solids than in gases because the individual molecules in a liquid or solid are closer together than the molecules in a gas. So it doesn't have as far to go to reach. If you remember the mini lab that we did in class with the marbles on the book, okay, the reason why the fourth marble moved, even though you didn't hit it, was because the energy from the wave from when you tapped marble number 1 moved through it, and they were packed tightly together. If those would have been spread farther apart, you would have needed a larger force or a longer amount of time for it to reach that fourth marble. Next bullet point, the speed of sound does not depend on the loudness of the sound. And loud sounds travel through a medium at the same speed as soft sounds. Now, you don't need to write down any of this. I already gave you the marble idea, okay? What I do want you to write down is this. The closer the particles, the faster they can transfer energy from particle to particle, which is a much simpler way of describing what happens instead of the marbles. Next on your notes, you should be writing the heading temperature and the speed of sound and adding to it the page number it can be found on. First bullet point, as the temperature of a substance increases, the molecules move faster, and this makes them more likely to collide with each other. Next heading, human hearing, and the page number, you can find it on your textbook. Vocal cords and mouths move in many different ways to produce various kinds of sound waves. Your ears, this is what I want you to write down, your ears and brain work together to turn the sound waves caused by speech, music, and other sources into something that has meaning. First bullet point. First, the ear gathers the sound waves. Next, the ear amplifies the waves. The next thing, in the ear, the amplified waves are converted to nerve impulses that travel back to the brain. And then finally, the brain decodes and interprets the nerve impulses.